Hello everyone, welcome to this week's session on Open Systems Interconnection Model Layers. The goals of this session are uh, actually first to understand the network connectivity and protocols and comprehensively understand Open Systems Interconnection Model, recognize the value of OSI on cybercrime investigations, and familiarize with the common terminology in regards to networks and cyber security concepts related with it, actually. In the early days of computing, computers were used as a standalone machines, and all work that needed cross computing was done manually. So computers also need language to speak with each other, and they need to speak almost exactly the same language, or they should understand at least the majority of or the framework of the language between them. And in the past, files were actually moved on disks from computer to another computer, and this was just a manual work for uh, PC users. And a new movement was therefore needed and was born. Actually, the OSI model is good fundamental information to have as you investigate what's unusual about networks. You also need to understand the OSI model because it's often discussed in understanding networks. OSI model helps us understand how computers share information and transmit data based on conceptual frameworks. And the OSR model was actually called or started with the open system movement, which called for computer hardware and software manufacturers to come up with a way for this to happen. However, to make this possible, standardization of equipment and software was indeed needed. And the OSI allows us to identify threats across your entire tech stack. And the OSI model will help you maintain a data-centric security posture. And basically, OSI describes how data is transferred from one computer to another computer based on some sort of standards. And this is a conceptual framework for how applications communicate over a network. The development of the OSI model was based on the secure premise that a communication task over a network can be broken into 7 layers, as you see on the right side of the screen, where each layer represents a different portion of the task in the networks. Different layers offer different layers of the protocol provide different services and ensure that each layer can communicate only with its own neighboring layers. So presentation layer can only communicate with application layer or with the session layer. Starting from the top of the protocol stack, this is actually, these all layers are called as protocol stack. Tasks and information moved on from the top layers until they reach the bottom layer, where they are sent over the network media from the source system to the destination. Each layer is designed to accept work from the layer above it and to pass work down the layer below it, and vice versa. And the first layer is the physical layer, and this is actually this logical model for how network systems are supposed to communicate to each other. When a networking problem occurs, physical layers to be first checked to see all of the cables are, for instance, properly connected, and that the power plug in, for instance, the power plug hasn't been pulled from the router, switch, or computer. So this is the electronic layer that helps us understand the communication through electronical channels or devices within the network. So the cable type, the radio frequency link, uh, as in Wi-Fi networks, as well as the layout of pins, voltage, and other physical requirements are important to discover the important procedures that the physical layer provides us. And the next layer is the data link layer. The data layer provides node-to-node data transfer and also handles error correction from the physical layer. This layer is the protocol layer that actually transfer data between adjacent network nodes in a wide area network or between nodes on the same local area network. So it could be utilized within the local area network or wide area network. And the data link layer provides the functional means to transfer data between network entities or nodes, and this might also provide the means to detect and possibly correct errors that may occur in the physical layer. This way, the data link layer is analogous to a neighborhood traffic cop. It endeavors to arbitrate between parties contending for access to a medium without concern for their ultimate destination. When actually devices attempt to use a medium simultaneously, uh, frame collisions occur. And the data link protocols specify how devices detect and recover from such collisions and may provide mechanisms to reduce or prevent them. So in order to understand the problems with the devices and the medium simultaneously within the network, you need to understand the data layer. The next layer is the network layer. This layer moves packets, and these packets are now actually called datagrams from router to router along the path from a source host to the destination hosts. It supports a number of protocols, including the Internet Protocol, Internet Control Message Protocol, Internet Group Management Protocols, which are very important protocols for computers to deliver information or packets. And the IP is the most widely used network layer protocol. Your internet service provider assigns a numerical label called the Internet Protocol IP address to identify your device among billions of others, like the telephone number you have. You need a phone number to communicate with another person and the telephone network. In a way, an IP address functions as an online home address because devices use IPs to find and communicate with each other. In terms of cyber crime investigation, IP address is one of the most critical information in your investigation. Unless you have the IP address, the uh, offender, you will not gonna be able to figure out whereabouts the offender. And IP uses header information from the transport layer protocols that include datagram source and destination port numbers from IP addresses. And the best routes through IP are found in the network by using routing algorithms. So special algorithms help the computer or the IP find the destination within the wide area network. So here you can see an example of an IP address, and IP addresses are usually represented in dot decimal notation consisting of four decimal numbers: first, second, third, and fourth, ranging from 0 to 255. The IP is the most widely used network layer protocol, as I already mentioned. Keep in mind, this is the most widely used network layer protocol. And the next layer is the transport layer, and its main purpose is to transport application layer messages that include application layer protocols in their headers between the host and the server. For the internet network, the transport layer has two standard protocols. The first one is the transmission control protocol, and the second one is the user datagram protocol. TCP actually provides a connection-oriented service, and it guarantees the delivery of all packets, of all application layer packets to their destination. So this is a guaranteed delivery system or protocol. On the other hand, UDP is different from the TCP/IP, even though it's also used for communication within the network. In a situation where there's no need to check for errors and correct the data that has been sent, this may not, using UDP may not pose a significant problem. So UDP can be used for a variety of purposes. UDP actually provides no frills connectionless service with just delivery and no acknowledgement. So your computer is not acknowledging the information but just receiving, and the server also do not expect an acknowledgement from other nodes, so that the network becomes more efficient in situations like there's no need for error checking or correction of the data that has been sent across the network. And UDP is much more efficient and the protocol of choice for real-time data such as streaming video and music. So think about that. You are listening a radio stations streaming and has millions of actually listeners, and it will be more efficient not to check for errors, and it's a music which you can later on listen, and it may not have crucial data, even though if you very much enjoy listening to music or streaming the music on the internet. And the next layer is the session layer. And when actually two computers or the network devices need to speak with one another, a session need to be created, and this is done at the session layer. This layer actually functions for coordination and termination between the applications at each end of the session. And this layer actually allows the processes to establish communication where termination and coordination are parts of the processes or steps or procedures in the session layers. The presentation layer is also, this presentation layer is also called the translation layer, and The data from the application layer is extracted here and manipulated as per the required format to transmit over the network. So the purpose of this presentation layer is to convert data from one format to another. The presentation layer represents the area that's independent of data representation at the application layer. In general, it represents the preparation of translation of application format to network format or from network formatting to application format. In other words, the layer presents data for application or the network. So keep in mind that this layer is important to actually to convert data from one format to another format. The functions of the presentation layer are first translation and encryption and decryption, and also the compression. So for instance, in encryption, the data encryption actually translate the data into another form or code. The encrypted data is known as the ciphertext and the decrypted data is known as the plain text. So keep in mind that the decrypted data is known as plain text versus the encrypted data is known as ciphertext. A key value is used for encrypting as well as decrypting the data in the presentation layer. And the other benefit of this presentation layer is to reduce the number of bits or the size of data traveling or transmitting on the network. So this provides an efficiency within the network. And the last layer is the application layer, which actually I'm pretty sure most of you are familiar with it and have been using the application layer, even though you do not conceptually name it. The application layer is the topmost layer in the open system interconnection model. This layer provides several ways for manipulating the data, which actually enables any type of users to access network with ease. For instance, hyper transfer protocol HTTP is an application layer protocol for transmitting hypermedia documents such as HTML, and you can also you have been actually using the application layer to access to another computer within the network, or to access to a remote file server. But keep in mind that the applications such as Firefox and Chrome and also the Outlook or Skype are the applications that utilize these protocols. We're not actually focusing on these applications by itself, but the protocols that they are actually using within the network communication. So these are the basic layers or fundamental layers that's important to understand the interconnection between computers or other types of mobile devices within the network. Understanding the OSI modeling is important for your understanding of networks, as well as for your future studies in regard to understanding cybersecurity, cybercrime, and actually network concepts. Thanks for listening to this lesson. I hope you will be able to understand more in-depth knowledge by considering this session. Thank you.